Next presentation is by Torben Kling Petersen about the status of Lustre as HPE, OpenZFS, performance enhancements, and other updates.
Torben Kling Petersen has worked with high-performance computing since 1994. After leaving academic life in 2000, he held technical leadership position in a number of tech companies, including Sun Microsystems, Oracle, Xerotek, Tex, Seagate, Cray, and from January 2020 at HPE. In the various companies, Torben has architected a significant number of HPC and HPC storage system, as well as worked with engineering to bring several new products to markets. At HPE, Torben currently works as the lead of HPC storage architect for strategic engagement in EMEA and APEC.
Thank you. I still don't know why I need an introduction. Probably most people here know me and so on and so forth. Any which way, the presentation, as you heard, was kind of a jack of all trades, and somebody forgot to turn off the phone. Anyway, so I will cover a number of things today. The main reason for that is that I had an ambition to give a bigger overview of everything we do at HPE, and obviously some of it I can't talk about because of NDA rules and what have you, and so on and so forth. So I picked out some of the, I call it the raisins on the cake in order to get some of the best things. So first of all, I will start with OpenZFS, and one of the main reasons for talking about OpenZFS is that, a few years ago there was a big, a lot of talks about OpenZFS and what it could bring to Lustre and so on and so forth, and that has kind of died out a little bit. It's not that it's not working, because it is. It's not that it isn't as good a player as anything else, but there are some issues with it. Now, we obviously have a couple of big sites in the US that runs OpenZFS on the systems. And they're doing that for the obvious reasons. I mean, if you compare the two systems and the two options we have today with LSKFS and OpenZFS, OpenZFS has a number of very interesting enterprise-like features, like compression, for instance, copy on write, built-in integrity, so you don't have to use T10PI or DPS2 or something like that has a little bit of overhead and needs to be done carefully. And then you got the snapshots. Honestly, snapshots on a Lustre file system that gets really large becomes very unwieldy, and I'm not really seeing that being a lot of requests unless it's a smaller Lustre file system with home directories on it or something like that. So there are some differences. There are also some similarities between them. The most important thing here, I think, is that that we still are talking about a fairly newcomer to the Lustre community. It's only been here for a few years, whereas LSKFS have been there essentially since the dawn of time. We've worked a lot with the OpenZFS community because we found a lot of bugs. We have submitted a lot of fixes to it, and you can see the list down to the right. And all of these things is in order to make sure that we can support this going forward. So today, any customer we have has the choice of going LSKFS or CFS or a combination of them inside the same namespace. And this is kind of where I'm going with this presentation a little bit, because one of the main reasons why OpenZFS is not as popular as LSKFS is this. Now, I've compared two different setups where you have essentially standard HDR. You have hardware Rocky running 200 gigabit network, so again based on Mellanox, but it's Ethernet. And then we have the same hardware in the latter one running either without compression and with compression. Now, if you just compare these two sets of columns, you see that on everything we do, whether it's direct I/O or buffered I/O, we suffer a penalty. It's not super great, but there is a penalty. The big penalty actually comes in the IOPS. We're losing a ton of IOPS when using OpenZFS. And there's really nothing we can do about it. Now, can compression help us? Well, on Flash, no. We lose even more performance. And it's even more obvious in the metadata point of view. So if I'm looking at a Flash-based system where I/O is key, the value I have of doing things like copy on write or built-in data integrity is totally negated by the fact that I'm losing a significant chunk of my performance. So most of our customers, and one customer in particular was NERSC, that originally decided we're going to use OpenZFS in the system. We ran all the benchmarks, we showed them all the things, and then switched everything to LSKFS because they just couldn't abide by losing that much performance. Now, we still have the guys at Oak Ridge, and we still have the guys at Lawrence Livermore insisting on running OpenZFS, but their systems have been sized to do that specifically and has other means to get performance out of it. So, in this case, for Flash, I would say, it doesn't really work, and especially if you look at the IOPS numbers. Consider, and I think I may have the numbers, I can't remember, but consider this: the impact of OpenZFS on metadata. It will grind to a halt. Oops, I wasn't wrong. Now, on disk, the story is different. So when you use a disk system, and essentially we have one JBOD here and two JBOD here, that's what the numbers mean, you can kind of see what we get for numbers. Now, the hardware-based RoCE solutions, whether it's InfiniBand and 200 gigabit Ethernet, is about the same level. You can see that scales linearly. It scales linearly to 2 JBODs, so we know we can scale that to almost any size. Using standard D-Rate 2 on these systems, we get lower numbers, specifically on the writes. The reads are pretty good, but the writes kind of suck. But that's because we have to do copy and write on everything. Now, if we add LC2 compression to it, the picture changes. Suddenly we get numbers that are higher than the hardware RoCEs, especially on the reads. They double. So in this case, these systems are essentially running the disk drives at a virtual 200 megabytes per second per drive. Now, obviously, the compression is done in flight. So, and I should also say, big caveat here: these are IR numbers, right? And IR files are easily compressed. So don't expect to see these things on real data. But we have done some tests with this with real data as well, and the compression performance is pretty decent using LC4. And we actually get numbers that are better than we have on the disks, as on the hardware RoCE side, whether it's InfiniBand or Ethernet. So what we're trying to do here is that, does it make sense in a tiered system or a hybrid system where you have a flash tier and a disk tier to run all disks on OpenZFS, and you run all flash and metadata on LSKFS? Well, that's currently what we contemplate, and we're probably going to do that as a standard going forward, still with a choice for the customer choosing whatever they want to do. But we think that, when you have a flash system, especially when you have a tiered system, and Carsten talked about the fast data, and the same concept there where you have a cold pool and a hot pool, or a flash tier and a disk tier. The disk tier is really your hot archive, right? That's where you have the data you need to access fairly quickly, but it's not the data you're using for the actual computation. That's on flash. And if we have that extra data security and some other of these features, especially the compression pieces, that makes a lot of sense to us. So that's one of the concepts we're currently working on. So it's interesting to see if anybody else have experience of running mixed file system inside of a single namespace, because I think that could be a way of the future. Now, when we're talking about performance data, one of the big challenges we see nowadays is the fact that, back in the day it used to be InfiniBand, and only InfiniBand. Now there's a lot of other things out there. And I'm not going to talk about Omnipath because we still haven't seen anything on 200 gig Omnipath that actually seems to work well, so we ignore this for now. But you have your InfiniBand, standard HDR, now NDR is creeping in from the right side of the building and so on and so forth. We have Ethernet 200 gig, and we actually have customers that prefer to run it in TCP mode and not RoCE mode for a number of reasons, because it's more simple to set things up and so on and so forth. And then, of course, we have what marketing calls the HPC Ethernet solution called Slingshot. And all of these do things differently. one Rocky is not the same as the next Rocky, or so one RDMA implementation, I should say, is not the same as the next RDMA implementation. And there are some differences. And making this work well together is really a challenge. So we run a lot of benchmarks. We have a very skilled benchmark team that does a lot of these things, both for customer tests, of course, but also internal, to kind of figure out how these things work. And we do this on every single release we have internally, so we do a lot of benchmarking. Now, what's interesting here is that we kind of looked at the latest generation we have. Everything is running on Lustre 215 client server side. Everything is running on the exact same setups, which is a single flash unit and also has 2 disk units behind it, and 20 or 21 clients. And we use the exact same hardware for all of these tests, so we can compare them fairly equally. So if you look at these numbers, you can see the performance numbers we have using buffered or direct I/O for, InfiniBand. You can see the same using for Slingshot, which is called KFI here. We also have numbers for TCP. And one of the things I rarely see anything out of, we did a test not too long ago, which I think is really important, is how does Elnet routing between those 2 fabrics work, between InfiniBand and KFI. Now, we always know that Elnet routing can do about 85% of the slowest interface, which is a good rule of thumb, but I rarely see real numbers. So that's why we added these as well. And as you can see, KFI actually outperforms InfiniBand in most cases. Not so on the read IOPS, but everything else is up to par. We're still trying to figure out the read IOPS thingy, that's probably a tuning parameter or bug we need to fix. But from a pure throughput point of view, that was a very hard word to say today, throughput point of view, KFI actually is on par or better than InfiniBand. Now, TCP sucks on writes. Reads are pretty good, but it sucks on writes. And if you do routing, as again, see, we're not quite up at these levels, but we get some pretty decent data. Again, we can't get 100% of the performance out of the system, but Elnet routing is actually pretty decent in these environments. Now, if we look at this from a disk point of view, again, you have the same numbers. KFI definitely outperforms InfiniBand on disk-based I/O. TCP is not that far behind. It's actually pretty good. There's a problem when we get to large amount of devices. We can't get the right performance of, but it's in the same ballpark. And the routing is, again, not quite on par, but not bad. I mean, if you look at those numbers, it's pretty decent numbers for an Elnet routed solutions. So one of the things I'm trying to say is that we try to shy away from Elnet routing mostly because it adds cost and adds another numbers, it adds more network, but sometimes it can solve problems that can't be done while routing inside a system. And we shouldn't be afraid of using Elnet routers just because there's a little bit of extra cost, because it actually gives you degrees of freedom you cannot achieve in any other case. And then that was also highlighted in the previous talk where that was being addressed as well. So I'm just trying to say that, don't discard Elnet routing because of performance reasons or cost, because it's not actually going to hit you that bad. Now, doing the same thing on IOPS, or maybe there, sorry, you can see that again, the performance numbers are in the same ballparks. We're a little bit slower on the KFI or the Slingshot parts. And again, that comes down to the fact that we haven't found the perfect tunings yet to do things. TCP is actually not that bad, but has a little bit of penalty. And the routing, again, slightly slower because there is an overhead, especially on multiple packages, but there is an overhead, and we can kind of get to the same number. Now, I'm not going through the numbers in detail, but you have them in the slide deck, so you can actually look at them and use them as reference points of what we can do with Lustre 215 today on some of the tunables we have. And if anyone is interested in looking at exactly what kind of tunables we're using and so on and so forth, we can supply that as well, because we don't keep that on our reps. Now, changing pace totally. And this is because, first of all, I did a presentation on this topic last year. And obviously a lot of things have happened since last year. But one of the things that really has change the way we look at data migration inside system is the fact that as we get into more AI, machine learning type environments where we have customers using both traditional simulation and so on and so forth, and also doing a lot of AI machine learning work and inference and what have you, we see a new type of users. Younger people with the laptops, with the notebooks, that really doesn't understand what a file system is. I need a bit bucket, and I need to find my files. With the fact I've generated 1 billion files over the last 10 weeks, doesn't matter, I want to find my files. And they do not know how to use Lustre. They do not know how to actually use any of the tools that we take for granted, because these guys are, used to just dropping a file and being able to find it after the fact. So what we see is a new era where we need to provide newer tools to manage these billions of files we create. By the way, have any of you ever tried to do an LS on 1 billion files? You know how long it takes?
Forever.
Well, actually, I timed it. So you can do an LS on 1 billion files, nicely distributed in directories, in about 56 days. So obviously, those tools don't work anymore. Now, one of the things, doesn't matter, but it is what it is. So one of the things that makes it complex is that we still have our computes. And I mean, this is a version of a slide I showed yesterday. I just want to go through it a little bit, where we can add local drives. These drives are now more efficient. We have, by addressable CXL drives and so on and so forth. We have much higher capacity and high performance PCI Gen 5 drives that can be used locally, but it's really hard using them for anything useful unless we add something like Deos onto that issue. And I'm not going to talk too much about Deos this time around, but we can also add traditional SSDs as local scratch, but unfortunately sharing data for that is really hard, as we know. And then we have some tools we work in the different communities like Maestro, trying to help how to address some of these things. And then we have our parallel file systems, whether that be in spectrum scale, Lustre, actually I should say storage scale nowadays, Lustre and the other things on it. And many of them are tiered. That means we have a flash tier and a disk tier, or a hybrid configuration. Some old school customers still prefer to separate them, but a majority, I would say about 80% of the systems that we build for customers today are tiered file systems. And that means you need to have data movement and data migration capabilities inside of the Lustre file system to do this. That's a lot of different names for it, but we all have the same concept of how do you policy-based move data from one tier to another, and so on and so forth. Luckily, we have good networks today, and those networks allows us to do a lot of things concurrently. So the isolated SSDs we have up here, obviously we can address them using PCC, for instance. Now, I haven't seen a lot of actual production use of PCC yet in the market, but there's a lot of interest in it. There are some challenges with it, obviously, but specifically, I would say, for the AI market, where we have these super powerful base pods or super pods, this makes a lot of sense. We just haven't found the right use case yet where it really makes a big difference, but it's something that should be looked at. And then we have the back end, which is something where we need archiving. And we heard Carsten talk about 700 petabyte of capacity on the back end. We have that in many, many places. Now, it doesn't need to be tape. It could be things like, disk-based tape, or what we call serial storage. It could be a data lake like Ceph or something else. It could be anything really that has a large capacity and a lower price point than a Lustre file system or anything else. And that also needs to be taken into care. And then you have the back end when we need to share that data over a long distance, whether that be through globals, through multi-site, or any other of these kind of solutions to be able to share data with sites that are more than a few miles away. Now, we shouldn't forget the NAS systems that is very common, or Ceph systems that many sites have, also need to be part of this picture. Because what we're really trying to aim for here is creating a single virtual namespace over this entire area, where we have web-based or cloud-based like tools allowing us to manage any and all data through a single interface. Now, this still doesn't exist. This is a vision statement. But I want to give you some ideas how far we come since then. Now, there are other solutions on the market today. None of them have the big picture, but they have parts of this. A lot of them are focused on more enterprise desktop type solutions, but again, there are pieces here and there that actually seem very useful. And we're looking at that on how we can incorporate that as well. So the vision statement is really we're creating a distributed system with local agents at every single time, distributed data movers that can be virtual machines spun up when needed and spun down and used for something else, and so on and so forth. But in order to create a flow of data, we also need a management of everything, and that's really what this comes down to. So we're not just talking about the different ways of things, because users need to do things, sysadmin needs to do things, we need to do things policy-based and so on and so forth. I know I'm probably running out of time, so I'm speeding up a bit. So there's a lot of aspects to think about here, and I really wanted to put it up just for reference as well. Now, the other thing we have is that we have a lot of different endpoints that have different ways of interacting, whether it's based on HSM or other types of POSIX limitations. We have the problem of how do you combine an object and a file-based solution into something that actually is coherent without having to translate everything at every given point. Again, one of the big problems we have. And then you have the different types of media that we always need. Now, we can always discuss the value of tape, but tape has been dead for 15 years, according to myself. I've been wrong for the last 15 years, so obviously tape still has a lot of life in it. And then we also need to be able to do reporting on this. As we mentioned earlier, it is really easy to move data, but it's really hard to monitor that data movement. So that needs to be a key point about what's in flight, what's online, what has been done, where is it, and so on and so forth, to make sure that we actually understand the state of a file at any given time. Now, this is a video that we made as a mock-up, or actually a proof of concept, that actually monitors 5 different file systems. And this is intended for users who are not storage savvy, who doesn't know how to write a SQL script, for instance, to do things. And it's about being able to find and use simple policies in order to set things up. So we'll let this play out a little bit. You can just see how the concept is working. And as I said, this is the beginning of the data migration facility solution that we have. Now, will it look like this when we're done? I don't know. Will we actually complete it ever? Because there's a lot of work to be done. I don't know. But it is a vision that we think is important for the future of parallel file systems in data centers, regardless of the use case. But as I mentioned, those new users who knows how to use a web portal to set up and create a virtual machine on Google or whatever, this is the same kind of concept. It's easy for them to figure out. It's easy for them to do. It's easy for these people to, manage their own files without having an expensive sysadmin that does all the work for them. And again, we come down to being able to not just see the files, but also get a deeper insight into what those files are and where they're located and so on and so forth. So again, categorizing files, finding files, being able to use those files in a dedicated manner seems to be very important, and I believe that it is the way of the future. Now, there's a lot of different alternatives for what this user interface could look like, but this is, as I said, one set of experiments we did not too long ago. Now you can see how some of these commands instantly translate into a SQL command and so on and so forth. Again, making it easy to do things. We still have to figure out, sometimes we may have these paths in order generated by the user because we know what the user's directives are. In this case, I used MP3 because I got about 1.5 petabytes of MP3 files on our Lustre file system, so we need to move them sometimes. Of course, I don't have 1.5 megabytes. I think all music in the world wouldn't be 1.5 petabyte in these things. Now, visualization, how these things are moving across the system is also, as I mentioned, very important. We need to be able to monitor this as well. Now, again, this may not be the end user being interested in it. He just want to know when it's done. But as a sysadmin, you might be interested in seeing how this actually works, or we creating bottlenecks, and so on and so forth. And we can compare it, because since you can add virtual data movers, you can add 1, 2, 4, 8, 16, how many you need for any specific job, we can also see that this scale is fairly linear. And that's, again, part of how we set these up. It should be very simple to do. If you just need to move a few files, you just use 1. If you need to move a terabyte of data, you use 2 or 4, and so on and so forth. And again, so far for the tests we've done, it scales pretty linearly. I think we ran out of nodes at 5, so that's as far as we got with this. So what I'm trying to say is that, yeah, we have a foundation today that could be useful, and we're also trying to use as much as the open source toolkits that's out there to do things. But there are a lot of interesting questions. First of all, do we really need this? I mean, this is an open question. Are we always going to have sysadmins that can take care of the files, or do we actually need to let the users manage their own crap in the file system? Because they generate so much data, we have no idea what that data is. Sometimes it's just totally unreadable because the titles or the names of the files doesn't make sense, or it's objects, that's even worse. You know, a Lustre and Spectrum scale really part of this picture going forward. Everybody's talking about object stores, forgetting the fact that object store is really slow compared to anything else. I would say it still has a lot of life in it, but it's one of these things we need to adapt to the big picture to be relevant going forward. And one of the other things that's really key here as well is that what do you do when you migrate to a system? Carsten, again, sorry I use you a lot, Carsten, but you had a good use case. How do you move 45 petabyte from an old file system to a new? That's not trivial. And I mean, Carsten made it sound simple, but trust me, it is a pain in the butt to do those kind of migrations, because you need to migrate, you monitor, you know, a lot of sleepless nights. So trust me, that's a big part of this as well. Now, there are a lot of tools out there, but no tool is perfect. There are better tools, worse tools, and you have to use multiple tools sometimes to get things done. And I wouldn't say, don't disregard rsync in the end, because it actually does work in some cases. And then we have the archiving solution, where tape. Should we still continue to invest in tape? Are there other solutions out there? Should we put it into, you know, glacier storage and accept the fact that if we ever need it back, it's going to cost a fortune, but at least we know it's safe, hopefully. But that is kind of where we're going with these things. And what is the next step? Now, I have a summary slide as well, which I'll skip because it's not really relevant. But I also want to give credit to the fact that I may sound like I did all the work, but honestly, I didn't. I stand on the, you know, corpses of a lot of my colleagues that are now helping out. So that was at the end of my talk. So questions, comments?
Okay.
So, thank you very much for the talk. I have one question regarding the compression with ZFS. So, I was working for years now on client-side compression inside of Lustre and coupling with ZFS, and we have a bunch of unaccepted pull requests for ZFS project where we have extended the interface so that the ZFS is able to understand externally compressed data and can give out compressed data so that Lustre can manage it inside. But it's kind of dead now, because we have just a bunch of students who do not know what a file system is, and we cannot do it on our own. So if you have interested and you think that this can be a crucial feature for spinning disks, which is also my opinion, maybe we could somehow revive this project and maybe push the actions on that.
I would definitely enjoy doing that. I mean, as I said, I still see compression as an important part of file systems going forward, specifically since a lot of files are very compressible. I mean, client-side compression is something that's been on the table for a long time. I mean, I think I talked to the people at DKRC about that about 8 years ago the first time, and we it looked really key, but there's obviously a lot of challenges there as well. And I would definitely enjoy seeing that moving forward, because it is one of the more interesting things going forward.
Other questions?
Little one for you. About the first slides, you did the comparison between OpenZFS and LDiskFS. I'm wondering, is it the same hardware or not?
No, it's the exact same hardware.
Exactly the same?
Yeah.
Okay.
I mean, our benchmarks setups are exactly the same.
And the question is, how was the load between your LDiskFS run and the OpenZFS run?
So the OpenZFS did consume more CPU power, but we were still talking about these systems are running standard AMD Rome CPUs, and we were hitting peaks about 45-50% utilization in most cases, whereas LDiskFS was about 30-35. So we're not even saturating a single CPU, and these are 32 core CPUs, so it's not even the biggest ones on the planet. So I'm not seeing the load on the CPUs being as high as it was originally. So a lot of the patches we've done is actually optimizing how the code operates in the system to streamline a little bit, because that also speeds things up.
Okay, thank you.
Okay.
Thank you.